Okay, we are live. I'm gonna go do it now.
Oh, we have one subscriber.
Four viewers.
Oh, no, they left.
So now our price is going to return to P3, our quantity goes back to Q3. If my quantity increased, if my supply increased too much, and this was my new price, firms would be earning a loss, firms would exit. If supply didn't ship enough, there would still be profits. In the long run, the new equilibrium will be exactly where the old equilibrium was in a constant cost market or industry. So we have an initial increase in demand. In the long run, that will lead to an increase in supply. This is not a concurrent shift. I know it looks that way. So price will go up. Whoa, price will go up for a short period of time, and then it will come back down in the long run. Profits and losses. Probably should have done this first. You compare price to average total cost. So if we're here and this is my price, and this is where I'm producing, and my ATC is above, say my price, and take your time here and figure it out, like, is this a profit or a loss? Well, logically look, price is $5, average total cost is more than that, 7. So then think, on average, I'm getting $5, it's costing me $7. That's not great. So I'm losing on average $2 per unit. All the units, you go up to ATC and over, and this would be my loss. Now, if my ATC were below, same thing, but now what I say is my price is 5, my average total cost is 3, I go from my price down to ATC and over, and this becomes my profits. Price is better than ATC. You always compare your demand curve to ATC, and that will let you know if they're profits or losses. We always produce where MC equals MR in perfect competition. Always produce where MC equals MR. So MR equals price, Mr. Dart. If MC equals MR, then MC equals price. In perfect competition, in profit maximization. So one of the things the AP exam likes to ask is, what is the shutdown price? And if I'm earning a loss like this, here's my ATC, I'm earning a loss, but here's my ABC. Even though I'm losing money and in the long run I'm going to exit the industry, in the short run, if I forget about fixed costs, my price is greater than my ABC. Price is greater than ABC, so I will stay open in the short run. Sports Authority in this area went out of business, or they said they were going out of business, but they kept selling goods because the price was better than the ABC. So everything below this, so the firm supply curve is basically the marginal cost curve greater than ABC. So if marginal cost or price falls below ABC, we call that the shutdown price. All right, let's do 3 monopolies real quick. Demand, and then we'll do down here. The marginal revenue deviates from a downward sloping demand curve because as you drop price for one, you drop price for everyone. So this is marginal revenue. Here's my marginal cost. This is profit maximization. You have to go from your MRMC up to the demand curve and over. That's price and quantity. This is going to be my proper monopoly. This I'm going to call, I don't think you'll see it, but this would be a natural monopoly. It's the same idea. Oh, I goofed on that one, didn't I? It happens. It's the same idea, except my marginal cost curve is a little different. We've already kind of talked about marginal revenue. Here's my MR. So then I go MC equals MR, price and quantity. And then the last one is a first degree price discriminator. And in this case, because when I drop my price for one, don't have to drop it for everyone. I charge everyone a different price. My marginal revenue becomes my demand curve. And I'm not going to put average total cost here or here because I want to show deadweight loss. Deadweight loss is when price is greater or not equal to marginal cost, or when demand doesn't equal supply. You know, demand is price, marginal cost is supply, so when demand doesn't equal price. Here we have price or demand, here we have supply marginal cost, and there's my deadweight loss. Same thing here, here's my price, here's my marginal cost, so this whole thing would be my deadweight loss. And here, since MC equals MR, there is no deadweight loss. Now what I want to do, so this would be a natural monopoly. It's not a big part, I'm not going to spend any more time on it, and that's first degree price discrimination. But I am going to spend a lot of time, or a little more time, on all the intersections of a monopoly. I have demand, I have marginal revenue, marginal cost, average total cost. So here is my profit maximizing price and quantity, where MR equals MC. The deadweight loss would be right in there. Now what I'm going to do is have my revenue maximizing. That's where MR equals 0. So I go up to demand and over. I'll actually call this P3. Socially optimal is where marginal cost equals demand. I'll call this P2. I go down Q2. And then the last one is fair market, or break even, Q4, P4. So P4 is normal profit. P3 is rev max. P2 is socially optimal or allocatively efficient, and P1 is profit max. Those are all the intersections of a monopoly. That's everything you'd be expected to graph. Monopolies and MOCOs are effectively the same thing, except in the long run, a MOCO cannot earn economic profit. They earn a normal profit, but they still produce at the profit maximizing point. So this is quantity and price. This becomes ATC. And this can exist. Natural monopolies definitely have this. Monopolies, oligopolies, but this is excess capacity. AP exam just wants you to know that MOCOs have this in the long run if they're profit maximizing. Why is this important? It explains MOCO behavior. MOCOs will increase production, or they want to increase production, they just need to increase demand. So kind of what happens is when we use this example, like if a book turns into a movie and 5 years later the movie comes out, the book gets re-released with a new cover. Or there's a 25th anniversary of this movie or that movie or the new album, or one band makes the Rock and Roll Hall of Fame, they come out with a different version. So that's a different version of the album. Or greatest hits. I like greatest hits are a great example of this, where they've already made all the songs, they've already put that work, they just make a collaboration album and re-release it. Can't believe I didn't think of that before. So that's a MOCO. MOCOs, even at profit maximization, in the long run, have deadweight loss. So in the long run, MR equals MC. Price is greater than MC, so that equals deadweight loss. But price equals average total cost, which equals normal profit. I'm not going to do too much of oligopolies or game theory. I'll just talk about dominant strategy and no dominant strategy. A dominant strategy is same decision every time, regardless of other actor, firm, person. In golden balls, if the opponent steals, you can either split and give them all the money, and you feel bad about yourself, poor Steve, or you could steal, you get nothing, but at least they get their, I don't want to be Steve. If they're going to steal, I want to steal. So we both steal. If they split, you can either get half the money or you can steal for all the money. Every time you're going to steal. In the prisoner's dilemma, if I don't testify, if my opponent testifies, I either go to jail, not testifying, for 20 years, or I testify, I go to jail for 5 years. I'm going to testify. If my opponent doesn't testify, I don't testify, I go to jail for 1 year, or I testify, don't go to jail. Every case, I'm better off testifying. That's a dominant strategy. No dominant strategy is you change your decision based on opponent. Basically, we don't need to do a whole payoff matrix. I have that online, and you guys got really good at this over the last week. This we need to spend a little time on, factor markets. It's about 14%, and let's talk about the value of the worker. What's valuable about a worker? They make things. So how many things they make? That's called the marginal product of labor. Each additional worker produces times the price of the good. So the marginal product of labor times the price, this equals the MRP, which stands for marginal revenue product of labor. As the firm hires more workers due to diminishing marginal returns, the MPL goes down. Since the price, for the most part, will be constant, especially in perfect competition, it makes it easier when we talk about perfect competition. The MRP looks like this. And it's the demand curve with factor markets, demand. Oh, I didn't talk about circular flow diagram. It's more macro anyway. Demand is firms, supply is workers. We're the supply, households. So X markets the spot, we have supply, we have D equals MRP. And in perfect competition, which is most cities, most labor markets, with wage, quantity of labor, the firms are wage takers. And that's because there's so many people looking for a job, there's so many people hiring, that whatever the going rate for workers in that area is, that's what a firm will be. If any of you want to start a business in Belmont, you want to start a shop in the center, you're going to pay people basically what other people in the center are being paid. So they take the wage, and MFC, it's marginal cost, in this case it's marginal factor cost. How much it costs to hire an additional worker. And since all wages are the same in perfect competition, they are wage takers, and MFC is horizontal. This is very similar to price taking, but in this case it's wage taking. If there's any change to demand of the product, that would change the demand of the firm. MRP equals demand. We call this a derived demand curve. That's because the demand comes from the product market. So if there's an increase in demand for ice cream and the price of ice cream went up, ice cream workers, the demand for them would increase in the market, D2, S equals MFC, and it looks like the firm is hiring fewer people. It certainly does look like that, but what happens here is the demand for workers increased in the labor market. Why did it increase in the labor market? Because it first increased